Okay, today we're going to finish the Common Core State Standard 8G5, and we're going to talk about, we are supposed to use informal arguments to establish facts about the angles created when parallel lines are cut by a transversal. Okay, so our question is, what happens when two parallel lines are intersected by a third line? We have this vocabulary here: parallel lines, transversal, alternate interior and exterior angles, and corresponding angles. So parallel lines and a transversal. So remember, if I want to draw two parallel lines, okay, I could indicate they were parallel by putting these little arrowheads on them. So those two lines right now are parallel. I use those geometric notation to indicate that. Okay, so those are parallel lines, and if a third line that's not perpendicular to any of them cuts across, or this third line that's not parallel to the first two cuts across them, we call this line right here a transversal. Okay, so this is two parallel lines in a transversal. Now, oftentimes, every time when this happens, 8 angles are created. There are 4 up here, and there are 4 down here. Okay. So you have these 8 angles right here. Now let's talk. Some really nice things happen when you have those 8 angles. So first of all, let's talk about corresponding angles. When you have two parallel lines in a transversal, we have these things called corresponding angles. Now I want you to think about where you've heard corresponding before. Okay, when we had two figures and we transformed them, so let's say that we had 2 triangles and we translated one triangle to the right and up. We called every vertice, like this vertex here and this vertex here, would be corresponding vertices. So it's the same vertex that's in the new triangle. Okay, that's what we call corresponding. So corresponding means there's some association, like it's the same angle but in a different position. So the same thing is going to apply here. When you have these 8 angles, the corresponding angles are going to be the angles in the clusters of 4. So this is the first cluster of 4. There's the second cluster of 4. Every pair of corresponding angles lie in the same position relative to their lines. Okay, so let's call this line 1 and line 2. In line 3, this third line is a special line, that's called a transversal. Okay, so in line 1, the angle that's to the left of the transversal and above it is angle 1. Now, in line 2, the angle that's to the left of the transversal and above the line is 5. So a pair of corresponding angles here are 1 and 5. Okay, now you can really see this because look at this line right here. If I were to take this line and this pair of in this sort of situation right here where the transversal cuts through that, and I were to just take this and drag it down, if I were to take this crossing right here and translate it downward right here, then angle 1 would lie right on top of angle 5. That's why it's corresponding, because if you translated this whole batch of angles downward so that it became this situation right here, then 1 would lay on top of 5, 4 would lay on top of 8, so angle 4 and 8 are corresponding. Okay, angle 2 would lay on top of angle 6, so they are corresponding, and angle 3 would lay right on top of angle 7. Okay, so they are corresponding because look at their positions now. Angle 1 is to the left of the transversal and above line 1. Angle 5 is to the left of the transversal and above the parallel line. Okay, now this really nice thing happens with corresponding angles, which is that they are congruent. Corresponding angles, because you're just taking these lines. Think about line 1 and line 2. They're parallel to each other. So the way that the transversal is cutting through them creates the same angle here and the same angle here. Okay, so these are congruent angles. But you also know that 1 is congruent to 3, right? Because 1 and 3 are vertical angles, so 1 and 3 are congruent, but 3 is corresponding to 7, so 3 and 7 are congruent. Also, angle 7 and angle 5 are vertical angles, so they are all congruent. Okay? Now, 2 is a different measurement because 1 and 2 create a linear pair. So 2, I'm going to mark with 2 of these little dashes. So 2 is corresponding with 6. So 2 and 6 are congruent angles. But you know that 2 and 4 are vertical angles. We learned that last time. So 2 and 4 are congruent. And 6 and 8 are also congruent because they're vertical angles. So 4 and 8 are also congruent. So when these two lines are cut, these two parallel lines right here, are cut by transversal, only two separate angles, you have a cluster of 8 angles that are created, but you only have actually 2 angle measurements that are created. Okay? So what we just learned from this page, and I'll identify the other angles in a minute. The corresponding angles, so angles that correspond with each other, let me mark them with a different color here. So 1 corresponds with 5. Okay. 2 corresponds with 6. 4 corresponds with 8. And finally, 3 corresponds with 7. Okay, so that's what we mean with corresponding angles. Alternate interior angles are also something that you should know. So think about this word, alternate, okay, interior. So when these two lines are parallel and there's a transversal that cuts through them, there are four angles that are created on the inside of the two lines. So this is line 1 and this is line 2. Okay, there are 4 pairs of angles that are equal, or there are four angles that are inside these two lines. 3, 4, 5, and 6 are inside those lines. So these 3, 4, 5, and 6 are interior angles. Alternate interior angles means that they alternate on the sides of the transversal that they're on. So there are 2 pairs of alternate interior angles. 3 and 5 are alternate interior, and 4 and 6 are alternate interior. So alternate interior angles are, there's a pair, angle 4 and angle 6 are alternate interior, and the other pair, angle 3 and angle 5. Okay? And what we know about alternate interior angles is that they are congruent. Oops. So alternate interior angles are congruent. Okay, and you can see that because of the, I guess we sort of eliminated all that stuff on the other page, but remember that we know that 1 and 3 are congruent because they're vertical angles. We know that 3 and 7 are congruent because they are corresponding angles, and 5 and 7 are congruent because they're vertical. And we also know that 2 and 4 are congruent because they are vertical, and 4 and 8 are congruent because they're corresponding, and 6 and 8 are congruent because they are vertical. Now look at 3 and 5 are vertical angles. Angle 3 and angle 5 are congruent. Okay, and angle 4 and angle 6 are congruent. So 3 and 5 are alternate interior, and so on 4 and 6. Alternate exterior angles, so just like there are 4 pairs, there are not 4 pairs, but there are 4 angles that are interior when a transversal cuts through 2 parallel lines, there are 4 angles that are created that are exterior. So the exterior angles are 1, 2, 8, and 7. Okay? Now, the ones that alternate, the ones that are on the opposite sides of the transversal are congruent. So 2 and 8 are congruent, and 1 and 7 are congruent. So here's your pairs of alternate angles. So 1, and I can actually just write that they're congruent, is congruent to angle 7, and angle 2 is congruent to angle 8. Okay? Now, same side interior are, just like 3 and 5 are alternate interior, 3 and 6 are same side. So they're interior, meaning they're on the inside, they're part of this cluster of 4 angles that are on the inside of the triangle, but same side means that they're on the same side of the transversal. So same side interior means that they are supplementary. So angle 3 plus angle 6 is equal to 180 degrees. Sorry, the measurement of those two angles. And angle 4 and angle 5, the measurement of angle 4 and the sum of the measurements is equal to 180 degrees. And likewise, same side exterior. So same side exterior would be 1 and 8. Okay? And angle 2 and angle 7. Because if we just highlight the ones that are exterior, 1, 2, 8, and 7, the ones that are on the same side of the transversal are 2 and 7, and 1 and 8. Okay? And they are also supplementary too. So we know the measure of angle 1 plus the measure of angle 8 is equal to 180 degrees, and likewise with 2 and 7. Okay? And we can use this to find x in these situations. So right here, the relationship between this angle and this angle is alternate exterior. So these are both exterior angles, and they are on different sides of the transversal. What we know about alternate exterior angles is that they're equal to each other. So I can set these two expressions equal to each other and then start to solve for them. So let me subtract 3x from both sides. And I'd have 2x minus 10 is equal to 60. Add 10 to both sides. So 2x is equal to 70. Divide by 2, and I have x is 35. Okay. Now, if x is 35, let me just put it into one of these expressions. 3 times 35 plus 60. So it's 70. It's 105 plus 60 is 165. Okay, if this is 165 degrees, and this is 165 degrees, we know that this is also 165, because they're vertical angles. This is 165 because they're alternate interior. Now, these are linear pair, so this is 15 degrees because linear pairs add up to 180 degrees. These two angles are vertical angles, so they are equal. Okay, likewise, I can get 15 degrees and 15 degrees in here. So just like I said before, when you have two parallel lines and a transversal cutting through it, it actually only creates two measurements. So here the measurements are 15 degrees and 165 degrees. Okay, here I've situated the parallel lines so that they aren't horizontal, they're diagonal, but they're still parallel. Okay, so here are parallel lines. If you don't like to notice them, if you don't like to look at them this way, you can feel free to turn your page so that they end up looking like this, if you'd like. And then this is 3x plus 40 here, and this is 2x. Now, there's not a direct relationship between those two angles right there. So let's try to fill in some things that we know. Okay, we know that 3x plus 40 is corresponding to this angle right here because they both lie below their respective parallel lines and underneath the transversal. So I can write 3x plus 40 right there. And I also know that these two angles form a linear pair. So that can help us set up this equation. Linear pairs are supplementary. Okay, so this is a little different than the one that we had before because the equation we set up before, we set the two expressions equal to each other. Whereas this equation, we are adding the two expressions together to get to 180 degrees. So if I solve for this here, 5x is equal to 140. So x must be equal to 28, right? Does that make sense? So 5 goes into 140. 10, 48. Yep, 28. Okay, so x is equal to 28. So let me just solve for the easiest one here. 2 times 28 is 56 degrees. These are linear pair here, so that I know that the other one should be 124. But then this is 124. this is 56. I know that's the supplement to 56 because this is 56 right here because these two are alternate interior. Likewise, that's alternate interior, so they're equal to each other. Then 56 would be here, and 124 would be there. Okay, so just make sure that you have that all in your notes. Now we have one more problem that's a little bit more complicated. You have the two parallel lines that are running straight horizontally, and then you have these, we actually have two transversals here. We have this green transversal, okay, so let me mark it in orange. We have this transversal right here, and we also have this other transversal right here. So we want to be very careful about what we're calling interior and exterior, what we're calling corresponding and what we name alternate interior, exterior, and same side interior and exterior, because we have two transversals here. Okay, so let's write the given information into the diagram. If angle 5 is 75 degrees here, and angle 2 is 60 degrees, we're supposed to use this information to find all the angles in the diagram. So let's just work in the clusters first. So if 5 is 75, we know that 5 and 8 are, and you might be able to do this by yourself, so you might want to pause the video and see if you can do this by yourself for practice. We know that 5 and 8 are supplementary, so we know that 8 should be 105, right? Because I take 180 minus 75 gets you 105, so 8 should be 105 degrees. Well, 6 and 8 are vertical angles, so that's 105. 5 and 7 are vertical, so that's 75. Okay, well, likewise, we can find the same situation over here. Okay, 1 and 2 are linear pairs, so they're supplementary. And 4 and 2 are vertical, so they're equal. And 1 and 3 are vertical, so they're equal. Now, in order to find 9, 10, and 11, what we're going to need to do is we're going to need to sort of extend one of these transversals. Okay, so let's just focus for a minute on the blue lines for a second. Okay, let's not focus on the orange one for a minute. The only thing, so 10 right here, notice that 10 is not an alternate interior with 8. Okay, the alternate interior with 8 would be 10 plus 11. That would be the alternate interior to 8. So 10 plus 11 is 105 degrees, but not 10 itself. Oh, actually, there's another thing that you could use. You can actually use that 10, 5, and 4 inside of a triangle. So the angles inside of a triangle have to add to 180. 5 and 4 together. So we know that angles 4, 5, and 10 have to add to 180. 5 and 4 together add to 135. So 180 minus 135 would be equal to, 45 degrees. So 10 must be 45 degrees. Okay. Now that doesn't necessarily help us with 9, but if we look at just the blue lines here, not on the orange, the blue lines here, 9 is the alternate interior angle to 5. We know that alternate interior angles are equal to each other, so 9 must be equal to 75 degrees. Okay? Now you can take advantage of, you can either extend the orange transversal to figure out what 11 is, or you might be able to just see it right now. 11 and 60, the 60 degree angle here, 11 and 4 are alternate interior angles as well to the orange transversal. So they're equal to each other, so this must be 60 degrees. Okay, and we can also check our understanding because all three of these angles, 9, 10, and 11, lie on a straight line. So they have to add to 180 degrees, which 60 plus 45 plus 75 do. Okay, so here we've solved all of these angles. Now there's many different ways to do this. I just used the ways that I saw as I observed this, but you may have observed other things on your own. So what we learned about today was what happens when two parallel lines are crossed with a transversal, and what happens with all of the 8 angles in this situation. All right, and we identified corresponding angles, alternate interior, alternate exterior, same side interior and same side exterior, and we talked about whether they were either congruent or supplementary to each other.